Okay, so A star search, fine with everyone? देखो it is not, है ना, but एग्जाम में कुछ ना कुछ A star से रिलेटेड मैं पूछ रहा हूँ, substantial marks, right? So you should go through it. I should be able to upload all these lectures maybe, let's say 48 hours from now. I've started editing them and so, I mean, okay. चलो, so we had talked about A star. ये लाइन इंपॉर्टेंट है, देखो जितने कंफ्यूजन होंगे इस चीज को लेके होंगे. एंड आई इंसिस्ट, GN मीन्स यूनिफॉर्म कॉस्ट. G मीन्स यूनिफॉर्म कॉस्ट की जो कॉस्ट है, राइट? बिकॉज else you can attribute many costs to all these nodes, and that's absurd, right? So what was about this slide? Let me just recap. What did we learn from this slide? That A star works, okay? And then from this slide we learned that it's not as straightforward, there are problems, okay? And specifically the problem was that a goal can be enqueued, but that does not mean that whichever is enqueued first is the optimal one. But which one is optimal? The one that gets dequeued first, okay? What from here? Not every H is what we are looking for, right? Because in this case this G was enqueued first and was dequeued first as well, but still this is not the best path because your H is not admissible, okay? H is not admissible. All right, so we had talked about these things. Is this equation clear? This is super simple expression, right? Just कि आपको थोड़ा सा 10-12 सेकेंड ध्यान से देखना है. ये वाला आर्गुमेंट किस किस को क्लियर नहीं है? रेज योर हैंड्स ऑनेस्टली. व्हाट डिड वी डू हियर? किस किस को क्लियर नहीं है? दैट्स व्हाट आई एम सेइंग, राइट? सो व्हाट इज इट दैट इज नॉट क्लियर? मैं यहां पे पूछ रहा हूं, तुम अलग जा रहे हो. इसमें क्या किया था ये बताओ.
इसमें तो मतलब अगर सारे पेजेस हटा देते हैं we'll get 50 which is the best case. We have weighted the best is 20.
Right. So now what is the problem with admissible heuristics? How many of you are okay with the concept of admissible heuristics? I'm not going to ask. Just raise your hands. How many of you are okay with the concept of admissible heuristics? See, in order to understand about admissible heuristics, we have to go back to this slide. In this case, H was 7, H was 6. And what does admissible heuristic imply? It simply says you can't use any H you wish. It must follow some rules. What are those rules? They are given by this equation, right? Those rules are given by this equation that says your H, and see, this is what they have written here. If you see this last thing, actual bad goal cost is lesser than estimated good. So this must happen, right? Intuitively, what is going on here? This cost that you are assigning to something, it is actually worse than what was actually given in the problem. So in some sense you are making my problem more difficult. That was not the idea, okay? So if you have any specific questions in this slide, any specific questions like this equation, that example. Hn in this case is 15. H star is 22, let's say. What is 22? Can anybody help me understand? What is 22? Optimal cost in this example. Because in this example, can I take this 15 wala path? I can't. Right? So I must go like this and so on. So let's say instead of 15, so let's say in this given example, minimum is 22. So what is 22 out of these quantities? H star n, right? What is Hn? Hn is 15. Because no matter what is the optimal path here, it certainly can't be lesser than 15. Sorry?
Best path.
I don't know what is 22, because see, if I knew best path has a cost 22, why would I solve? So I am given this maze, so think of this as a very big maze, jisme we can't really imagine what is the best path until we go and compute. So we are saying we are not computing this 22. This can be 22, this can be 18, this can be 96, whatever it is, it certainly cannot be lesser than 15. So what we are saying, it certainly cannot be lesser than 15, but is it certainly greater than 15? So greater than 15. So whatever this best path is, that is your H star n, उससे कम ही होगा this 15. This is 15, you can take it 10. So any number lesser than 15 is just fine. Actually any number lesser than 22 is just fine. But we don't know what is 22. So let's say if I take this to be 21, how would I prove that that my goal is actually greater than 21? Right? But in this case, why 15 is a good number for us? हमने कहा कि remove all the mazes. In presence of mazes, you can't do better than. So remove all the mazes, because in presence of mazes you can't do better than absence of mazes. I repeat, in presence of mazes you can't do better than in the absence of mazes. Make sense? आप समझ लो, ऑलमोस्ट यही क्वेश्चन मैं मिड टर्म में पूछ रहा हूं, नहीं समझ में आया तो अभी पूछ लो. हाँ 15 से 0 इज द लोअर बाउंड. हाँ मेज के बिना 15 है, बट इफ यू थिंक कि मेरे को 15 नहीं रखनी है एच की वैल्यू, आई वांट टू कीप इट 10, गो अहेड एंड कीप इट 10. किस चीज का? दिस वन. हाँ राइट. हाँ सो क्वेश्चन राइट. Right. So we are not bothered about what is the cost, we don't care. What we care is that H heuristic should be lesser than H star. So it should lie in this range. It can be 15, it can be 10. In fact, if this is 22, it can be any number between 0 to 22. You are just putting a constraint on H. Whether it makes sense or not, that is not our, we don't care. What we care about is H is admissible only if it is between 0 and the optimal path. Any number, in that case your A star will be optimal. So this can be 15, this can be 10, this can be 2, this can be 0, this can be even 22. The problem, more you move this side, you have no idea what is H star. If you knew what is H star, you wouldn't be doing all this. More questions here. More questions एकदम पूरा. मेरे को मत लेने दो नया लेक्चर. कितने अच्छे बच्चे हो तुम, चाहते हो मारे जाओ. चलो next. So we talked about the optimality of A star. We talked about this proof. Any questions here? Go through this, okay? While I will not ask you so this question is not coming in the exam that write proof for optimality of A star, right? But I might ask you some logical argument that makes use of some of this. So you should understand the argument rather than mugging up the whole proof. Okay. So for example, Fn equal to Gn plus Hn. Now I know Fn is less than or equal to Ga. How do I know this? Okay. These small equalities, inequalities. Chalo, next. For example, how do I know Ga is less than Gb? Because A is optimal and B is suboptimal. It is given. So that's why you don't have even equal to here, because it is provided to you that B is actually suboptimal to A. Okay. And then how do I reach from to this? Fa is less than Fb? Because both are goal states. So H is 0 for both of them. Okay. By the way, how do you know H is 0 at goal? How do you know H is 0 at goal? मतलब ऐसे ही बोल दिया किसी ने? हाँ. If you are at the goal and you know it is goal, then what do you know? Then what do you know about this H star? You are at goal, so H star is 0 because this information is given to you. So best UCS value, so best path to reach goal from itself will be 0. So there necessarily H is 0 and it is 0 for all goals. It does not matter suboptimal or not so. Okay. So I repeat, I am not asking you this proof per se, but ये जो छोटी छोटी चीजें थी that you should know. And you should of course know that A star search is optimal provided H is admissible. Now since we have proven A star is optimal, can you prove UCS is optimal? So A star reduces to UCS when H equal to 0, hence UCS is also optimal. Alright, properties of A star. So can you help me figure out now what are UCS versus A star contours now? ये वर्ड कितने लोगों को पता है contours? What does it mean? मशीन लर्निंग में भी किया होगा. What does it mean?
ऊपर से 3D प्लॉट को देखते हैं तो डायरेक्शन बताते हैं कंट्रोल
और 3D ना हो तो
उसका 2D
कॉस्ट फंक्शन की टर्म्स में देखा होगा आपने, राइट? बट लेट मी नॉट डाइग्रेस, लेट्स लीव इट. यूनिफॉर्म कॉस्ट एक्सपेंड्स इक्वली इन ऑल डायरेक्शंस, दिस वी हैव बीन टॉकिंग अबाउट. A star expends mainly towards the goal but does hedge its bets to ensure optimality. So something like this. You won't be going in all the directions. Of course, it will not be a direct line joining this one, but you will explore much lesser than what you would explore in the UCS. So I saw some animation on LinkedIn, right, where one was comparing optimal route from Bangalore to Delhi, and he ran Dijkstra's algorithm and he ran A star. A star was much faster than Dijkstra. Of course, they both will do the same thing, but A star was much faster because it was exploring much lesser nodes. And how can you do that? Because what extra does Dijkstra does? From source, it will give you best path to all other nodes. In this case, you are not looking for all other nodes. You are looking just for goal. So there is a room to improve. There is a room to do better than Dijkstra. In Dijkstra, it will go and touch every node, not just touch it, but also find what is the best path. In this case, it's okay even if you don't touch all the nodes. You just have to talk about the minimum path to that goal. Okay. So which one is this? एक बार देख लो यहाँ पे UCS, uniformly expansion. Okay. Now this was greedy. This won't happen either. Now so this is A star. Okay. You are not exploring everything. You are moving in the direction of goal. And now, if you see in this case, what was happening earlier in case of UCS? The whole grid was explored. Right? So, your search space has reduced a lot. Almost half of the grid you are not even going. Okay? So, greedy, if you see, was much faster. UCS, if you see, I can see only this particular place that was not taken. इससे तो रहने ही दो, छोड़ो. Right? This one, if you see, is A star. I don't have any animations. Right. So, if you see, only this particular place was left. Otherwise, in UCS, you explored everything. In case of greedy, much lesser. But in case of A star, somewhere in between. But you have left significant portion of the search space. A star has a lot of applications. Okay. So, कौन सा गेम है? आई डोंट नो. डूम है क्या? मैंने AOE के अलावा और कुछ नहीं खेला है. हाउ मेनी ऑफ यू हैव प्लेड AOE, एज ऑफ एम्पायर्स, और हाउ मेनी ऑफ यू प्ले? हाँ, ओके. हाँ, नहीं समझा. ओह, अब पहले ही टाइम नहीं मिलता, टाइम मिलता है उसमें वही खेले. हाँ, सॉरी, से दैट अगेन. राइट, मल्टीपल गोल्स. मल्टीपल गोल्स मीन्स राइट. राइट. नहीं, so because see, you are assigning cost, so there might be multiple ways of doing things, but there will be best way of doing something. And if you have multiple best ways of doing same thing, let's say I have 3 goals with same cost, go reach to anyone. For example, in chess, you can have multiple ways to reach to check and mate, right? So they're talking about optimality in this sense doesn't make much sense. Because, okay, we will talk, because see, right now we are talking about one player search. It is just one player thing. Chess is a 2-player thing. So let me take my argument back. Things won't directly go there. Because you play your turn, and now what adversary is going to do, that is not at all in your control. You can only think of the complete tree, that these are all possibilities that my adversary has. But that tree quickly blows up. More questions? आई एम सीरियस, मेरे को सिलेबस मत बढ़ाने दो मिड टर्म का. चलो, लैपटॉप लिट्स डाउन भाई. यस, all right. So you see, A star has a lot of applications and all diverse: video games, pathing. So you can see this in Google Maps, resource planning problems, robot motion, language analysis, machine translation. Not here anymore, by the way, not as much, right? Not as much, but still, because these days here transformers are doing much better. But anyway, since Berkeley has mentioned it, let me not remove it. All right, so done. Again a demo, okay. So ये लो. Okay, so your goal will be still just one, the one that maximizes or minimize. So what was the alternate name for this course that they suggested? Remember first class में क्या था अपन? Computational rationality. But what was that other slide जिसमें we were doing something? 4 words. Maximize. So 3 words: maximize, expected, utility. Expected, right now we are doing maximize utility, right? So whichever goal maximizes the utility, that is the goal you are preferring. So now let's go with this one. Which one is this? This one? A star? This one? DFS. This one? Replay? एक बार रिप्ले, बीच में थोड़ी सी गड़बड़ की थी अपन ने. BFS, right? Because shallow waters and deep waters, they are the same. It is not differentiating between the cost. Whichever is the shallowest path, you are taking that. Okay? So this has higher cost compared to this one. Now in this case, UCS. This is more like UCS. Everything else was fine. Chalo, done. All right, so now we start with how do you create admissible heuristics. We have already talked a lot about it. Creating admissible heuristics, and it is super easy, right? It is easier than what we have discussed until now. Most of the work in solving hard search problems optimally is coming up with admissible heuristics, right? So once you are Once you have come up with the admissible heuristic, you are done. Often admissible heuristics are solutions to relaxed problems. Often admissible heuristics are solutions to relaxed problems where new actions are available. Remember, what was the relaxed problem in case of that Pac-Man? You removed all the mazes and now you know this is a relaxed version of the original problem. Manhattan distance will give you the best path. In this case, what was that?
Removing the roads.
Yes, taking roads will certainly be longer than the direct straight lines, right? So this, in this case, what is the relaxed version? Take this map, just look for the straight lines, straight line distances, because your connectivity through roads is certainly going to be, let's say through roads, right? Whatever that distance is, that is h star. But if you relax this problem and if you talk only about straight line distances, will this happen? And you are done. Okay? Make sense? So admissible heuristics are often useful to write. ये गेम पता है? What is the goal? What are the states? How many states? What are the actions? How many successors from start state? What should be the costs be? Right, so let's answer these questions first. What are the states? See, it is up to you to decide what is it that you will call a state. So you are supposed to make a tree out of this and so on. What are states? State is a transition. Transitions, they will somewhere come here, right? You take action, you go from one state to other, that will be a transition. हाँ, एकदम सुपर आसान चीज है. The first thing that you can think of is the answer. So what is a state?
Condition of board after a particular.
क्या क्या क्या?
Board condition after a particular.
Right. So basically any snapshot of this board, that's a state. So how many states are possible? Give me an upper bound, because you know there are so many things that cannot happen on this game, right? There are some positions that cannot be attained. So you won't have all possible states, but total how many? 2 to the power? Why 2 to the power 9? So why 2 to the power 9? Awesome. एक टाइल पे या तो ब्लॉक होगा या नहीं होगा. Is that the problem we are trying to solve here? No. 9 to the power 8? How come?
There are 1 to 8 numbers and 9 positions.
Right.
So at each time there will be probability of either 1 to 3 to 8. So there are 9.
No. No. So there is no replacement here. Once 7 is here, 7 will not occur anywhere. So why 9 to the power 8? So there are some arrangements that are not possible in this, we are ignoring them. Arrangements कितने लोगों को पीएनसी पसंद नहीं था? Permutations and combinations. So 9, only 9, awesome. अब y 2 to the power वाले कौन कौन है ये बताओ मेरे को पहले. When will you have this 2 to the power something? If I were to place 9 pellets here, then you can say either there is a pellet or there is no pellet. So those arrangements will be 2 to the power whatever, right? Okay, right. Now we are talking. Okay. It will be 8 factorial or 9 factorial? But that will give you upper bound, right? There are many positions that are not possible in this. So simply open this, put it here. In how many ways can you arrange these 9 things? 9 factorial. Okay. Now this 9 factorial is an upper bound. I am repeating it. There are so many positions that you can't attain in this. All right now. So how many states? We have a huge upper bound. 9 factorial is a super big number. So many states will not be there, not even half of that. What are the actions? So basically you can shift this blank. You can shift this blank up, right? So if blank is here, you have only 2 options, but this is same as what we were doing in Pac-Man. Okay. So what are the actions? You can shift this blank, or if you want to say, you can shift these tiles. Same thing. How many successors from the start state? Let's say if this is the start state, how many successors are possible? 4. If start state were this, 2. If start state were here, I mean blank were here, 3, and so on. Okay. What should the cost be? Yes. So what should the cost be? Cost किसको assign करोगे? When you go from one state to the other, you incur cost. How many? So, but let's say if you go from here, so let's say you take this action, bring 6 here. Have you changed the state? So it's better if you give me cost of just this transition. You want to call that cost as 1? So moving 1 Okay. So क्या बात कर रहे थे अपन? Cost. So what should the cost be? So let's say you are saying कि if you change this state to this state where 6 comes here and blank comes here, cost is 1. Puzzle 1. Heuristic is number of tiles misplaced. So पहले एक बार मेरे को बताओ, how will you start from this state and reach to goal state? एक बार draw करो इसको. So whatever it is, this is my start state. How many children for this node? 4. Wherever I go, how many children will be there? 3. Okay. 3 for everyone and so on. So it's a exploding tree. All right. Now somewhere down there you will have a goal state. Okay. And you are supposed to give me the optimal path, right? Cost, laptop lids. Okay. Next. So you are supposed to go from this start state to goal state. You have a tree, how do you search? And you want to use A star. We have seen that all these techniques that we have learnt until now, BFS, DFS, iterative deepening, UCS, greedy and A star. Now we want to use A star. So how do I use A star? So yes. Number of tiles misplaced. Why is this admissible? क्विज किस चीज की है? मतलब कौन से सब? हाँ, मैथ्स. ओके, मैथ्स 5th सेम में कौन सा? ओके. हाँ, नंबर ऑफ टाइल्स में तो ये काम आ सकती है थोड़े बहुत. ये लेक्चर परम्यूटेशन कॉम्बिनेशन तो अपन कर ही रहे हैं, उसमें है क्या? ये लॉजिक है. लॉजिक. नंबर ऑफ टाइल्स मिसप्लेस्ड is your heuristic. Why is this admissible is a question that I am asking you. एक बात बताओ, यहां से यहां तक जाने का कॉस्ट बता सकते हो मेरे को? इन दैट ट्री दैट वी वर ड्रॉइंग, इफ वी न्यू दैट कॉस्ट वी वुडंट बी सॉल्विंग इट. आई वॉन्ट टू गो फ्रॉम हियर टू हियर. यू नीड टू एस्टिमेट H. Number of tiles misplaced. What is H start? इसके हिसाब से मेरे को H start की वैल्यू बताओ. Everybody is misplaced. So H start is 8 because everybody is misplaced. Now how? So why is this admissible? Why is this admissible? अपन ने अभी बहुत देर बात की है इस पे. See, if you were counting moving this as one cost, unit cost, will it cost you just 8 steps to reach here? No. So how can we say that this is a relaxed version of the original problem? So for a heuristic to be admissible, it must be relaxed version of the same problem. So in this case, how can you say it is the relaxed version? Look at this cartoon. So you can just remove and put it on its place. This problem of going from here to here, following all the rules, will certainly take greater than 8. Okay. So this is admissible. This is a relaxed problem heuristic. Now some statistics. So average nodes expanded when the optimal path has 4 steps. So let's say this is your goal, start state. When the optimal path has some 4 steps, UCS expands 112 and this heuristic expends 13. 8 पे 6339. If the optimal node is at 12 steps are required, UCS expends 3.6 million and this heuristic expends 227. So you are getting a speed up of roughly 4 orders of magnitude. If you were using just UCS, you will expend how many states? 3.6 million. In this case, just 227. Okay. I'll do these 3 and then we go. This is second version. So what if we had easier 8 puzzle where any tile could slide any direction at any time ignoring other tiles? ये समझ के मेरे को H start बताओ. पिछले वाले में क्या था? I took one tile and placed it on its place and called cost is 1. अब आपको इसमें cost compute करने का तरीका थोड़ा सा change हो रहा है. It is not same as this last relaxed version. Same, something else. देखो, what if we had an easier 8 puzzle problem where I could slide any tile could slide any direction at any time ignoring other tiles. So for example, 5 is here. What will be the cost of moving 5 to its place? 2. Because ignoring 6, you can slide it here and then slide it here. Give me the total H start. What will be the cost for 7? What will be the cost for 7? 3. So 3 plus 1 के लिए 3. So let's start with this. 1 के लिए 4 है क्या? 1 2 3 3. Okay. One, two, three. Okay. Now 3 for 1. What is for 2? 1. So 3 plus 1 करते रहो. What about for 3? 2. Keep on doing this. Total sum will be. So this is total Manhattan distance and that gives you 18. Okay. Now tell me, for which version of the relaxed problem? So the last version was closer to 0 or this one is closer to 0? Remember, we said when H is 0, it is also admissible, but that is of no use because you are talking about UCS. So this was H equal to 0 and then H star. We said the more you move in this direction, lesser number of nodes you will expend, better will be your A star. So we were very close to this 0 in this case. Okay, this is not 5, it is 0. Which heuristic is better, the previous one or this one? Previous one? Why previous one? Let's, so ये देखो and then tell me. In case of tiles, 13, 39, 227. In case of Manhattan, 12, 25, 73. Why? Why are you expending lesser? Because let's say if previous heuristic was here, what you have is something here now. Because this heuristic is a relaxed version of the original problem but is still going to take more number of steps compared to the previous heuristic. More you come towards H star, better will be your A star. And if you reach H star, you can just directly reach to goal because you have everything. Next, after this, we go. Okay. So what about using the actual cost as a heuristic? Would it be admissible? If you start using the actual cost to reach goal as a heuristic, will it be admissible? Yes or no? Okay. Would we save on nodes expended? Okay. What's wrong with it? We don't know it. Okay. So with A star, a trade-off between quality of estimate and work per node. If you don't want to put your energy, you can put H equal to 0 for everything. You are back to UCS, you will be expanding as much as you can. If you start putting some non-trivial admissible heuristics, then you get something meaningful. So I think that's a good point to stop. Yes. Enough for today. Attendance कहाँ पे? अच्छा, किधर नहीं है attendance? So let me see. जो सो रहे एक बार उनसे पूछ लो, उन्होंने अपना नाम लिखा है ना इसमें? कितने लोग नहीं हुए यहाँ पे? क्या फोक्स, या तो मैंने काउंटिंग गलत की है या कुछ लोग इसमें, या दो लोगों के इसमें साइन नहीं है. सबको लगता है उन्होंने साइन किए, फाइन. हाँ, सही बात किसके लिए? मेरे को फर्क नहीं पड़ता, उनके लिए खराब है ना जो आए हैं और अटेंडेंस भी नहीं. या कोई ऐसे लोग बैठे हैं जो कोर्स में रजिस्टर्ड ही नहीं है. चलो